Imagine it's 6 p.m. in Bangalore. A political rally is announced near Cuban Road. Within minutes, traffic starts spilling into the neighboring roads, intersections become bottlenecks, and thousands of commuters are stuck. At that moment, traffic authorities have to answer three critical questions. Where should officers be deployed? How many barricades are needed? And which roads should be diverted? Today, these decisions are largely based on experience and manual coordination. But what if we could predict the impact of an event before the congestion ever happens? That's exactly what TrafficGrid does. TrafficGrid is an AI powered traffic command center that forecasts event driven congestion and recommends optimal manpower, barricading, and diversion strategies in real time. So, this is the TrafficGrid Command Center dashboard, providing a real time citywide operational view of Bangalore's traffic network. At the top, commanders can immediately see the number of active incidents are currently being monitored, planned events scheduled for today, personnel already deployed in the field, and are forecasting performance. The second row focuses on operational effectiveness, including delay hours avoided, reduction in incident duration, plan acceptance, and personnel utilization. So, as you can see, the heart of the traffic grid is the interactive map of Bangalore. It gives commanders an instant city-wide view of what's happening on the roads. The red markers indicate high impact incidents that require immediate attention. The green markers represent low impact incidents, and the green markers represent planned events such as rallies or construction activities. And the blue routes are AI generated diversion plans. Using the timeline controls, the commanders can move from 24 hours before an event to live monitoring and finally post event analysis, enabling proactive traffic management instead of reactive firefighting. But a city commander doesn't want to manually inspect hundreds of markers on a map. They need to instantly locate a specific road or event, understand its predicted impact, and receive an executable response. So, now I'll hand it over to Nishant, who will demonstrate how Traffic Grid Search and Recommendation Engine transforms a traffic event into an actionable deployment plan.
Thank you, Ayush. Let me show you how a traffic commander would actually use traffic grid in a real life scenario. Suppose an officer receives information about an event near potholes. Instead of manually scanning hundreds of incidents on the map, they simply search for the events or road using a search bar. Within seconds, traffic grid zooms directly to the affected area and highlights the impacted zone. Once the event is selected, our forecasting engine immediately predicts the impact. In this case, the predicted severity is low, the probability of escalation is 22%, the estimated duration is 21 to 119 minutes, with a median of 63 minutes. The event has a risk score of 67% based on historical and contextual factors. And we found 5 similar events from our historical data to support this prediction. Instead of relying purely on experience, commanders now have a data driven understanding of the event before taking action. But prediction alone isn't enough. The next question is, what should we do about it? That's where our optimization engine comes in. Resource allocation. Based on the predicted impact, Traffic Grid automatically recommends 6 personnel, 2 barricades, 3 divergent routes. The system also identifies the best control points where officers should be deployed. Here, the system recommends 2 nearby control points. For each control point, it tells us the number of officers required, the number of barricades needed, the estimated number of lanes affected, and even the nearest police station from which these resources should be dispatched. They eliminates manual coordination and significantly reduces response time. On the map, the orange circle represents the predicted impact zone. The blue markers indicate recommended control points, and the highlighted routes are AI generated diversion routes computed on the real road network. Traffic Grid evaluates multiple alternatives and recommends the route with the highest quality and the lowest congestion risk. Once the commander is satisfied, they can either accept the plan and immediately dispatch the instruction to the field officer or adjust the recommendation based on real world constraints. And the most important part is that after the event is over, officers provide feedback on the actual duration and effectiveness of the plan. Traffic Grid uses this feedback to retrain its model, making future predictions even more accurate. So, unlike traditional traffic management systems that only visualize congestion, Traffic Grid predicts, plan, executes, and continuously learns from every event. Handing over to Yash.
Now that Nishant has accepted and deployed the officers to this location, let's just see how the on-site mobile application will look like for the officers. Let's suppose I'm the on-site officer to whom the location is assigned. I'll just put my badge ID here and then I can select the station which says Cuban Park. Then I can choose my language. I can choose my preferred language. We have offered three languages, and the system can be extended to multiple languages later. So these are the nodes which are assigned to me. Basically, these are the locations which are assigned to me. So through this application, officer can add status note, upload photos from the incident location, and perform GPS check-ins to verify their presence on the site. This basically allows monitoring and documentation of situation in real life, and most importantly, this field feedback becomes a critical part of our post-event learning system. So basically, since on-site officers experience the incident firsthand, their observations will help us to evaluate the incidents and the effectiveness of the platforms and its recommendations and predictions. This creates a reinforcement learning through human feedback mechanism, where a real-world outcome continuously improves future decision making. Over time, the system learns important operational nuances that may not be visible in historical data set alone. This results in an increasingly accurate prediction over the period of time. So, to conclude, one of the biggest advantage of platform is that it enables proactive traffic management instead of relying on traditional guesswork. In conventional systems, traffic officer often have to make decision based on the limited information and experience. While experiences are valuable, and guesswork can lead to many delayed responses, inefficient resource allocation, and unnecessary operational costs. Our platform empowers the traffic authorities to move beyond the guesswork and make data driven decisions. By analyzing historical patterns, real time events, and predictive insights, officer can proactively secure accident prone areas, and they can respond to debris and road blockages faster, and they can prevent any further secondary accidents and deploy resources when they are needed the most. Our long term vision is to create a safer, more efficient, and a maintainable road network for Bangalore. And the solution is just not limited to Bangalore. Any city with a robust traffic data collection infrastructure can adapt this platform. The architecture is highly scalable, and it supports flexible deployment models that can be replicated across different regions with minimal modifications. Thank you.